Hi friends, here is a wonderful problem. Number of odd integers between 100 and 200 that are divisible by 3 but not by 7. Right. Let us break this problem into parts. Odd integers divisible by 3 is one part, not by 7 is the second part. First, let us try to find odd integers that are divisible by 3. So when we have to find number of integers that are divisible by 3, we can say in 100, how many 3 multiples are there? 100 by 3, floor of that is 33, right? For example, all numbers 6, 3, 6, 9, 12, 15, etc. All of these are multiples of 3. How many of these are there? These will be 100 by 3, right? Floor, because we don't want the decimal part of it. So 3 goes in 100 how many times? 33 times. Right. 33 into 3 is 99. One left. So we have 33 multiples of 3 in 100. Right. Similarly, we have 66 multiples of 3 in 200. This function is called floor function. Right. Floor of 1.5 is 1. Floor of 2.3 is 1. Any integer less than or equal to that number. Right. So between 100 and 200, how many multiples of 3? This 66 minus this 33, which is again 33. Right. How many multiples of 3 are there between 100 and 200? That is the first one. That is 33. Now, but we want only the odd multiples, right? We don't want the even multiples. Even odd integers between 100 and 200, right? These multiples of 3, some of them will be even, right? So, for example, 102 is also part of this. 102 is even, right? 102, 105, 108. We don't want 108, 102, these kind of ones, right? Then how do we do this? How do you do this? One thing, because if it is between 100 and 200, we can easily see and calculate because these are smaller numbers. But we should find a way where it works between 2000 and 10,000 or bigger numbers also. That's why we should solve this systematically. Right. So, what are the odd multiples of 3 between any two numbers? Between 100 and 200. Right. We know the total multiples. For odd multiples, let us subtract the even multiples of 3. How do you find even multiples of 3? Even multiple of 3 means it is a multiple of 3 and 2 simultaneously, which means it is a multiple of 6. Right. Now, if you subtract all the 6 multiples from the total multiples of 3, that means the what that will be left is only odd multiples. How many 6 multiples of 3? It is again same, right? 100 by 6, floor of that is 16. 16 times 6, 16 multiples of 6 are there till 100. And 200 by 6, which is 33. 33 multiples of 6 are there till 200. So this 33 minus 16. 17 multiples of 6 are there between 100 and 200. So these 17 are actually even multiples of 3. Right. So total multiples of 3, odd multiples will be this 33 minus the 17. So 16 will be odd 3 multiples of 3. Very good. Fine. So what are on this 16? 16 are this 105, 111, like this. All these multiples. Right. These are all odd 3 multiples of 3. Now, what we want, this is not all. This is that we want odd multiples of 3, but not by 7. But not by 7. How do you do what is not by 7? Right. What is not by 7 is the trick here. Now, first let's see what is by 7. How many multiples of there are multiples of 7 also. Right. We want in this 33 which are not divisible by 7. First, let's see between 100 and 200 how many multiples of 7 are there. Again, 100 by 7, first 114 multiples of 7 are there. Next 128 are there. So, total is 14 multiples of 7 are there between 100 and 200. Right. 100 and 200. 14 multiples of the 7 between 100 and 200. Now what we want? We want odd 3 multiples and 7 multiples, but not 7 multiples. Right. Whatever in the 60, whatever are the 7 multiples are there, we have to remove them. Right. So for example, if I draw the Venn diagram, Venn diagram will be something like this. Left side is odd three multiples, and right side is seven multiples. Odd three multiples, this entire circle is 16. And 17 multiples, this seven multiples, its entire circle is 14. Right? We want what is there in middle. Then only we can calculate, right? What is this? What is this? What is this? We know the total of this is 16, the total of this is 14. Right? Odd three multiples and seven multiples. What we want is something, the ones which are both odd three as well as seven multiples. So what we want to do? We want the intersection of this first. That is odd three multiples also, seven multiples also. How do you get this? The odd three multiples and seven multiples is total 3 and 7 multiples minus even 3 and 7 multiples, right? Total 3 and 7 together minus even 3 and 7. Right? What is total 3 and 7? What are the multiples of 3 also, 7 also? That will be 3 sevens 21 because these two are prime numbers. 3 sevens 21. Whatever is a multiple of 21, that is definitely a multiple of 3 also, multiple of 7 also. Right. So what are the total multiples of 3 and 7 together? That will be the multiples of 21. Right. That is multiples of 21. But what are the even multiples of 3 and 7? That will be the multiples of 42. Right. Multiples of 42. Because then even multiples of 3 and 7 means multiples of 6 and 7 together. Right. So that is multiples of 42. So what we want? Odd multiples of 3 and 7 means total multiples of 3 and 7, that is total multiples of 21, minus even multiples of 21, that is multiples of 42, minus multiples of 42. Right. Total multiples of 3 and 7, that is the multiples of 21, minus even multiples of 3 and 7, that is multiples of 42. Right. What is multiples of 42? Again, 100 by 42, there are two multiples. 242, there are four multiples. Between 100 and 200, there are two multiples of 42. So what is the total 21 multiples? Earlier we have discussed 21 multiples are between 0 and 100, there are four. And 100 and 200, 200 by 21, total 9. So total 0 and 209 are 9 are there. Till 100 there are 4. So 5 21 multiples between 100 and 200. So this 5 minus 2, total 3 multiples are this odd multiples of 3 and 7. Right, please understand this. Total odd multiples means total multiples of 3 and 7 minus even multiples of 3 and 7. That means total multiples of, that is multiples of 21 minus multiples of 42. Right, between 100 and 200. This is 5 and this is 2. So this is 3. Right. So total multiples, odd multiples of 3 and 7 is 3. That means this part is 3. This part is 3. What is this part? This part is 16. Total is 16. So this is 3. This is 30. And what is this part? This part is 11. 14 minus 3. So now what is the question? The question is about what is this part, right? Which are odd 3 multiples, but not 7 multiples. That means the area of this. This is that area, right? Which are odd multiples of 3, but not multiples of 7. So the answer is 13. The answer is 13. Right. This is how we have to approach these kind of problems. Right. Because it is 100, I can manually calculate and find out if it is 3 or 13 or 11. Let's say it is about the bigger numbers, 1000 or 5000, whatever those numbers. Then, whenever we are facing this kind of odd multiples problems, we have to subtract even multiples from the total multiples. That's easier approach. Right, guys? And how do you find total multiples? Total multiples is whatever in that number by that number. Whatever, let's say in 1000, how many 3 multiples are there? Then 1000 by 3. Floor of this. Right. And between 500 and 1000, how many are there? That means minus 500 by 3. Right. In the first 500, how many multiples are there? Then the total minus that first 500. Right, guys? Hope you understood this problem. This is a very nice problem, very interesting problem, and very important problem in permutations and combinations, which you can see this in number theory also, permutations also. Right. This is a very important counting principle. Right. This is basics of counting. Hope you like this. Thank you, guys.